Hey guys, so today is going to be another quick, easy lesson. We're just going to be reviewing all of the stuff we've done so far this chapter. The only difference is for each of the questions, you're not going to be told what type of ratio to use. So you could be using tan, sine, or cosine. And also this is going to be a mixture of both finding sides and finding angles. But there's nothing new that we're going to be doing in this lesson. So this is lesson 2.6, all of the trig ratios. Step one is, of course, going to be label your triangle, which has been step one all along. And then step two will be use the correct ratio based on which sides you have and which sides you're looking for. So use SOHCAHTOA or your formula sheet to figure out which ratio you need to use in order to find whatever it is that you are looking for. And that'll just be based on which sides you have. So we're just going to do through two quick practice problems. Example one, I have said solve the triangle. And so solve the triangle just means find all of the missing sides and all of the missing angles. So I'm going to start by finding some of my missing sides. So right now I have the side that is across from the angle, so that is my opposite side. Across from the right angle is my hypotenuse. So we have the hypotenuse, we have the opposite, the other side must be the adjacent. Now I need to find both the adjacent side and the hypotenuse side, doesn't matter which of those I start with. I'm going to start by finding the hypotenuse, so that'll be like my first step. And so in order to do that, because I have the opposite and I'm needing the hypotenuse, according to my SOHCAHTOA, when I have the opposite and need the hypotenuse, I use sine. So the sine of the angle is opposite over hypotenuse. I'm going to plug in my angle of 38 and my opposite side of 19, and then I need to solve for x. Of course, because x is on the bottom of this fraction, I need to multiply by x on both sides. That leaves me with the sine of 38 times x equals 19. And of course, to get the x by itself, I need to divide away the sine of 38. So 19 divided by the sine of 38 is 30.86 centimeters. Okay, so that is my hypotenuse. I can now write it in over here, 30.86. I'm now going to find my adjacent side. I am going to use my opposite side still, even though I could use the hypotenuse. It's better to use a side that you were given than one that you solved for, if possible, just in case you solved your hypotenuse wrong, then you'll still get the adjacent side right. So that is going to be my next step. Let me just grab some scrap paper here. Okay, so this time, because I have the opposite and I'm looking for the adjacent side, I'm going to be using tan. So the tan of my angle is opposite over adjacent. So that is the tan of 38 is 19 over x. And then just like on the previous example, we multiply by x on both sides. That's going to leave me with the tan of 38 times x equals 19. And of course, in order to isolate the x, I'm going to divide by the tan of 38 on both sides. then I'll just plug that into my calculator. So 19 divided by the tan of 38, and I get 24.3 centimeters. So 24.3 centimeters. The very last thing I need to do is figure out what angle C is. And I could use a trig ratio to do that, but there's actually an easier way because I already have one of the angles, plus I know that one of the angles is a right angle. The easiest way to figure out what angle C is just going to be to take 180, which is what the three angles in a triangle add up to, and subtract the two angles I know, the right angle of 90 degrees and the given angle, angle A, which was 38. If I subtract those, 180 minus 90 minus 38, I get 52 degrees. And that is what my angle C would be equal to. Sorry, that's an angle symbol. Okay, again, if you would prefer, instead of solving it like this, if maybe you don't have memorized what the angles of a triangle add up to, then you could certainly solve it by using any of your trig ratios. You would just say, for example, again, you could use any of your trig ratios, but say I used that the tan of the angle is its opposite, which would be 24.3 over the side that's adjacent to it, which would be the 19. In order to isolate the angle, I need to take the inverse. So the angle is the tan inverse of 24.3 over 19. So the tan inverse of 24.3 over 19 is 51.978, which would, of course, round to 52 degrees. Okay? And you could have just as easily used sine or cosine. If you had used sine, you would have used the opposite divided by the hypotenuse. If you had used cosine, you would have used the adjacent divided by the hypotenuse. But regardless, that's 4 different ways that you can possibly solve for that angle. All of them are equally valid. Okay, let's look at a second example here. This one at the bottom of my page here. So for this one, I haven't told you that you need to solve the triangle. I've just given you an angle that you can solve for. Again, step 1, label the sides of this thing. So our hypotenuse across from the right angle is going to be the 35. The opposite side across from the angle I'm given is that one there. And then 21 is going to be my adjacent side. This time, because I am dealing with the adjacent side and the hypotenuse, according to my SOHCAHTOA, I am going to need to use cosine. So the cosine of the angle is adjacent over hypotenuse, which is 21 over 35. Because I'm finding an angle, I take the inverse of it. Cosine inverse of 21 over 35, which is 53.13 degrees. And that would be your final answer. Okay, so nothing we haven't done already. We're just kind of putting it all together at this point. Also, just to flip back to the previous question, sorry, I just realized I forgot to put my little inverse sign in there, but I did put the tan inverse in my calculator, so it is still the right answer. Okay, that is it for today's lesson. We only have one more lesson left in this unit.